Okay, let's go ahead and start this next lecture. This is broadly about making things. I want to talk about products that reached very large scales of dissemination and look at why. What are some of the technical and kind of cultural and socioeconomic factors that led to that? I want to talk about making most critical modules, MCMs, as a follow-on to our design process we talked about yesterday. And I want to talk a bit about prototyping and why you do that and different techniques you can use. Anybody know what the picture is that you see here?
Ford Model T.
Yeah, it is Ford Model T. Good call. Yep. And what was unique about this production method?
Just mass production.
Yeah, mass production. It was the assembly line. You know, it enabled Ford to produce a high-quality product very cheaply because they were efficient in doing all the steps of production. Okay, so in this lecture, I'm going to go back to this bar graph a number of times. And each bar represents a different product we're going to talk about. You know, all of these are products that have reached very, very large scales of dissemination in emerging markets. This is not a comprehensive or like absolute list as far as like which products have been the most largely disseminated. These are just examples that demonstrate different levels of scale, and these are certainly some of the products that have reached some of the highest scale. So don't think of this as like the definitive, absolute, you know, one and only top list. But I want to give you a sense of perspective and have you think about what led to these products being so highly disseminated. And these are in scales of millions, right? So 1,000 millions, a billion, over a billion products. So let's start with the first one. This is a multi-part, multi-component product. Do you have an idea of what it is? Over a billion distributed over the time since it's been manufactured. What type of product do you see all over the place? Bicycle. Yep, exactly. And let's go back into the history of this product and why it's been so successful. This is a picture of a very early variant of what's called a safety bicycle. And why it's called a safety bicycle is that it replaced the penny farthing, which were death traps. So the common bicycle before the safety bicycle had this big front wheel. Have you ever seen a picture of one of these? Are you guys familiar with these? Yeah, big front wheel. Your center of gravity is quite close to the contact point, right? And it's very high. So if you have an obstacle right here, it will create a big torque that is going to flip you over the wheel. But it's a relatively simple mechanical system because you're directly driving the crank right at the wheel. So in the 1880s, this safety bicycle became more popular, and it's safe because you're shifting your center of gravity so much farther back than the front wheel, and so your likelihood of going over the handlebars is much, much lower. So it was much, much safer than penny farthings. And I just explained it's safer because of the restoring moment, because of where your body weight's positioned relative to the contact point of the front wheel. There's about 100 million bicycles produced per year, 80% of which are in China. There's also a lot, you know, there's millions, hundreds of millions produced in India also, some in the EU. And there's been 4 billion bicycles produced since 1950. And all of them are basically based on this platform. So, you know, even a high-end racing bike or mountain bike or a relatively lower cost bike that may be made by like Hero cycles here, all the same basic architecture. Isn't that amazing that it hasn't really changed since the 1880s? Still, seat in the same place, chain in the same place, crank in the same place. Yes, we use carbon fiber and more gears and stuff, but still basically the same product. Some of the aspects that have led to this high dissemination is one, of course, safety. Two, it's a very affordable means of transport, and it's fast transport. It converts this very natural biomechanical motion of movement of your legs into a quite efficient means of transportation because it's got such low rolling resistance. And it's produced at massive economy scale. It's made everywhere. It's used everywhere. It's repaired everywhere. And these are other topics that I think are important to getting something product at really high scale if you can get it to the people and have them maintain it pretty easily. And you're going to see that in some more examples. Okay, so the next product, over 100 million, well over 100 million, 200 something million sold. Any ideas what it is? It's a cell phone, but it's a specific cell phone. It's the cell phone that really opened up emerging markets. Yeah, we talked about it yesterday. It's the 1100. Yep, exactly. And so, can you spot features on this phone that maybe resonated with users here that made this more adaptable, adoptable in this market, that appealed to consumers? Large battery, exactly. Yeah, had a what? Torch, yeah. Flashlight, yeah. That's right. You say torch more often than flashlight, right? Yeah. So a torch. What else do you see here?
It's very sturdy.
It's very sturdy. Yeah. What makes it sturdy?
It is solid and the weight of it is also very light. People have a feeling that it's sturdy.
Oh, yeah, it has a feeling of like quality and sturdiness. I agree with that. Compact design, I agree. Yeah, it fits in your pocket. What? Yeah, exactly. What else in the rugged design? Can you see anything here that's rugged? Yeah. It doesn't have individual keys, and there's very little place for dust to go inside. Yeah. Any other features that you can see just looking at it? There's one more that kind of stands out.
Display.
Yes, what about it?
Display is not easily breakable.
It's also black and white, so it's cheaper, and it's also lower power than a color display. So yeah, so you picked up on most of the features. So one of the big ones was the torch. This phone, when I was working in East Africa in the early 2000s or mid 2000s, this was a very popular phone, and they used to call it the Maasai phone. The Maasai are a tribe there that do a lot of cattle herding and farming, and they'll be out in rural areas walking around at night with their cattle, and they want to see, so they use the torch. And so people associated the phone with the Maasai because they used it all the time. But there was about 250 million Nokia 1100s that were distributed. This was an example of, I think, a very successful ethnographic-driven design exercise because they went into the target markets around the world and understand these features and user needs, or the user needs that drove the features. And Jan Chipchase, the guy I told you about yesterday who wrote the book, Hidden in Plain Sight, he was really integral in this process. It weighs, it's funny, you said it weighs a lot, but it's actually rather lightweight. Actually, if you compare it to like an iPhone now, and it will float. So it had the reputation that a fisherman could drop it in the water, and if you just dry it out, it'll work again. And it won't sink to the bottom, so you lose it. You notice the keypad. The keypad's also silicone. Oh, it says silicon. I should change it to silicone. And so it's very grippy, and so you can hold it easily. You won't lose your grip. We talked about the reduction of dust coming into the phone because of the single keypad. It had these unique features to a cell phone at that time. It had like all the core functionality a person would want. It can be your alarm clock, it can be your phone, it had some games in it, you play Snake on it, right? And it had the torch, the flashlight. It had really good talk time, but look at the standby time, 400 hours, right? Really low power consumption when it's not being used. And they designed that specifically because in the markets where it was sold, people may not have power every day to charge a phone, right? They'd have to go many days and just have it on them and then charge in between. It was a relatively low-cost phone. So like when I was a kid in like the late 80s, early 90s, cell phones were these big bricks and they were like $1,000, and this was like $15 to $20. This was at a price point that made a phone really affordable to a big swath of the population. And then here's another really important point that's interesting. And I'm touching on this because, do you remember yesterday I talked about this idea of design freedoms? Elements of the market that are unique to the market that you can exploit to your advantage. You're going to see in these examples that a lot of these products identified a design freedom that could help them disseminate the product and really leverage it. So what happened, and I don't think Nokia planned this, I think part of this was luck, but what happened is when the 1100 was released, Reliance Telecoms here in this country announced that they had a major price discount on calls. They changed their pricing structure. So it made using a phone more affordable to the user, not just the purchase cost, but the operation costs. And that helped prime the market for the dissemination of this phone. So if you're a designer and you're reading in the newspaper that Reliance is going to change its price structure and you're working on phone designs, you should notice that. You should be like, whoa, that's going to help me. And so I want you as designers not to just be looking at the physical thing you're designing or the CAD work you're doing, but look at the whole ecosystem that's around your design and to look at these factors that can help you, right? You're going to see some more examples of this. Okay, that's the Nokia 1100. The next product has done 175 or more now million variants in emerging markets. And it is a multi-part complicated device. What do you think it is? No, not there yet. What? TV? Yeah, about a TV. Yeah, all the variants of TVs, I'm sure, are much more than this. But this is a pretty single variant. No, not high. That's around 40 million or so. This is 175. This is, I'll give you another hint. This is a product that we would typically not discuss in like a developing world technology class where we talk about like water filters and other things that help people. This product doesn't have a good reputation. This is not a good product. Well, it depends on how you define that. It does a lot of harm potentially. What is it? AK-47. Yep, exactly. The Kalashnikov. Yep, it's the AK-47. And I'm not, I want to be very careful when I talk about this. I'm not trying to praise this. I'm not trying to advocate for it. I think it's important for us as engineers and designers to be agnostic when we look at products like this and try to understand why did this reach such high scales of dissemination, right? Yes, it does terrible things to societies. You could also advocate that it does good things for like militaries. But independent of all that, it's a machine that somebody designed that has reached large scales of dissemination. So let's think about why. So 175 million variants, and there has been different variants, but all of them look pretty similar to what you're seeing since 1948. It has a very simple construction. Instead of being like a bunch of machined billet pieces of steel, it's mostly made from sheet metal. And they intentionally designed it with really low tolerances, so that helps part interchangeability, but it also makes it less susceptible to jamming. So you can like literally drive over this with a car, you can throw it into a puddle of mud, and it'll just keep working. It's like really tolerant of errors. Extremely rugged and reliable. It's incredibly simple to use. You can literally train a child to use it in 10 minutes. And that's why I showed the picture of a child soldier. This made it more adoptable, right? There's really nothing to it. You cock it, there's a very simple safety, there's a very simple selector to select between semi-automatic and fully automatic, and you can strip it in like a minute and take it apart. So it's made to use with relatively low educated people. It uses low weight, high velocity ammunition. Now, the background of military rifles is that 200 years ago, 150 years ago, people used much bigger rounds, much heavier ammunition, much longer distance travel. And they realized that you don't actually need to shoot somebody over that super long distance like a sniper. You need to shoot over a few hundred yards. And if you use smaller ammunition, you can carry more of it. So assault rifles have kind of evolved to using high velocity, lower mass rounds, and they're getting kinetic energy out of velocity instead of mass, and you can carry more. So the ammunition is important in being able to carry a lot of bullets. It was given away by many countries, by the USSR before the fall of the Soviet Union. This helped with the dissemination, and it also helped make people accustomed with it and liking it and wanting it more. So MIT does the same technique with SolidWorks. you know, the design software. SolidWorks was designed by one of our alumni. They give it to MIT. They let every student use it for free. What happens? Students like it. They get accustomed to it. When they go start their own companies, they buy SolidWorks, right? So you tend to, it's brand loyalty, right, is another way to put that. It was manufactured everywhere. It was manufactured in the markets where they were going to use it. So all these countries had their own production facilities. So they saved on importation costs, they saved on transportation costs, they had repairability because they had part supply right there. And so instead of having this central hub of Russia producing everything, they said, no, we're going to get the gun produced near where it's going to be used. So that's another technique you can think about.
It must be transferred, right? The design must.
Yeah, they licensed it to other manufacturers. Yep. Okay, next product. What do you think it is? Any guesses? Good guess. Honda Super Cub. So I'm going to show you a video. I wasn't able to download this video, unfortunately, but I'll play it off YouTube. This is, do you guys know who this is? James May. He's a presenter from Top Gear, or was on Top Gear, now the Grand Tour on Amazon. So he's going to tell you a story about the Super Cub.
It's been in production since 1958. It has been made in over 20 countries around the world. It is a product of the rising sun on which the sun never sets. It's, but they're very cleverly spaced. 2 and 3 are for sort of cruising along. 1 is for climbing up hills, very steep hills as it happens. So you bought a 50cc motorcycle, but Honda gave you a mountain.
You can go to the link and watch the rest of the race. So there was many hints in that film about both the social, and the user-centered, and the technical factors that led to this being such a success. Did you pick up on them? One-handed, yeah. Some other things? The delivery? Woman-friendly, very good. Anything else? What? Yep, can climb up, yeah, steep terrain. What'd you say? Tires, big tires, yeah, nice. You picked up on a lot of them, yep. So 87 million produced in history. It was designed, I think this is one of the first true reverse innovations, because they were designed with that core functionality, super high value product that would work in developing and emerging markets, but they also made it very appealing to developed countries. To give you a bit more historical perspective, back then, 50cc motors. Why 50cc is important is that in many countries around the world, it's the engine size where you do not need a license. Any bigger, you need a license to ride it, but if you make it 50cc or smaller, anybody can ride it. Even children, I think, in the US can ride it. I don't know what the law is here, but that's why they made it 50cc. And at the time, 50cc motors were pretty low power. They were about 1 horsepower. And Honda did a lot of good engineering to make a much relatively higher power engine of 4.5 horsepower. So it made it a lot more functional. They, and actually that's another important, before I go on to that, that's another important point. That's a regulatory standard. That's not just power for the sake of climbing hills and carrying a load. They had to understand the government regulations globally to understand that, you know what, it's going to let us sell more motorcycles if people don't need a license, right? Not a technical factor, a regulatory factor, but they read that market. 17-inch wheels for bumps, you picked up on that. And so to compare that, I'll talk about that next. To compare that, like scooters of the day of that era, do you know what a Vespa is? You have a variant of it here, but they have much smaller wheel sizes. And the original Vespas had like, I think 8 or 10-inch wheels. So they'd be a lot rougher on bumpy terrain. But with a bigger wheel, you get less of a horizontal reaction force when you hit a bump, so it'll roll over it more smoothly. So 17-inch wheels were important. Also remember, like in the time of history we're talking about, we're only 13 years after the end of World War II, right? Where Japan was bombed out by the Americans. So the infrastructure wasn't so great and the roads were pretty rough. So they designed for that. They made a smoother riding vehicle. It had a pressed steel frame and a plastic fairing. This whole fairing in the front, this white piece, is a single piece of injection molded plastic. It's not multiple parts. And the frame is most of it is just two halves of stamped steel put together. So you compare that versus a tubular frame where you have to weld a bunch of tubes together. This is way, way cheaper to manufacture. As they talked about in the film, you can ride it with one hand, so you can see the guy delivering all the pairs of shoes there because he's holding on with only one hand. Yeah.
But that's not the safety regulation. Like in India, if we are designing a motorcycle,
Yeah.
so the user centric, if we design according to user centric, then we will most probably will have 3-seater motorbike. But that's again the safety regulation. So as a designer, what should be categorized? As a safety regulation or the user centric?
I think you have to be able to sell the product, right? And so you have to know the safety regulation. If your product was illegal because it had 3 seats, then you won't be able to sell it.
No, means if like a Splendor bike, it has a single seat that can have a 3-seater. But like
Yeah.
a bike like Glamour or Igniter, it has 2 different level seaters.
Oh,
That kind.
so you said the designers did a good job if they had 3 people sit on the seat?
Means which one is good design? Means able to cater for a 3-seat or 2 different levels?
I would look at which sells more. I don't know. I don't know the vehicles well enough to comment. I would think in this market, well, it depends. You have competing factors. Like one, let's say you can seat 3 people, but maybe one looks better or one is more aspirational, and that's why people buy it. So it's hard. From your description, I can't tell you which is better. So it depends on what people like and what people buy. So yeah, we talked about riding with one hand. It was relatively inexpensive, so around $2,000 in today's dollars. What do motorcycles cost here? They're less than that, I think, right? How many rupees? No, not $100. 700 you can get a motorcycle? Wow, wow, that's low. Okay. So, this is certainly less expensive than most motorcycles in the US, but relatively low cost. They were producing 100,000 per month, so they figured out the design for manufacturing so they could produce this very rapidly and efficiently. Again, they produced it everywhere in the world where they wanted to sell it. Here's the list of countries where they produced this motorcycle. Isn't that crazy? So all their target markets, and most of these are emerging markets, they produce variants. You produce a variant here, actually. I forgot to say that. It's not titled the Super Cub, but I've seen things that look very close to this here. If you've ever been, this is like Vietnam. You see pictures like this in India too, just like, it's almost like a school of fish moving together. So you can ride them in very tight confines. But here's what I think is maybe the most brilliant part of this product. They had an ad campaign that went with it that said, you meet the nicest people on a Honda. And so look at this picture. This is a very 1960s American focused picture. I recognize that. But it's showing what looks like a college campus. She has her books. She's studying. She has this clean-cut, nice boy. He's cleanly shaven. He's wearing nice clothes. He looks like the nice type of man that maybe you want your daughter dating. He's not threatening. And so they're projecting this image of the type of people and the aspirational aspects of the product. Why that's so important is at that time, let's contrast that to what motorcycle riders looked like. So this is from a movie. This is Marlon Brando, a famous actor, from a movie called The Wild Ones. And it's a movie that depicts these motorcycle riders as like criminals. They're like tough guys that get in fights and you don't want anything to do with them. So people who ride motorcycles had that bad reputation. Also, if you look very closely, he's actually riding a Triumph right here. And Triumphs, Harley Davidsons, all the motorcycles of that era required a lot of maintenance. You'd have to tear down the engine and rebuild it every few thousand miles. You'd have to get all greasy and dirty. And it was really a subset of the population that was willing to do that much maintenance. Instead, Honda made an incredibly reliable, easy to maintain bike so a person who doesn't have any technical ability could use it. So they opened up the market of potential consumers. not just kind of men who like to play with grease and get dirt, people like me basically. Instead, they had more consumers. So I love that. This is probably my favorite example in this lecture. I love it. Okay, the next one. What do you think it is? It's also a vehicle. I'll give you a hint. Any idea what it is? It's a vehicle. It is a car. It's a small car. What is it? Close. No, not Volkswagen Beetle. More than that. Nope. They've upgraded the design over years, but it's had the same title, the same name. Yeah, same model. No. What?
800.
No.
No.
No. It's the highest selling car in history for a model. Yep. Toyota Corolla. And this is what it looks like through history. This is the original on the top, and this is a more modern one, right there. Corolla. Yep. So let's go to the background of this. There's been 40 million of these produced, most highly produced car in history. And they launched it following Japan's expanded infrastructure after the 1964 Olympics. This is another example of a design freedom that happened that I hope Toyota's engineers picked up on. They realized it, because what happened is when they hosted the Olympics, remember this is only 19 years after the end of World War II. So they went through a very difficult economic time. They rebuilt themselves. They wanted to showcase to the world that Japan was open for business, and they upgraded all the roads. That made a vehicle, a car, much easier to drive on the roads than previously when the roads were bumpier and rougher. So the infrastructure in the country helped get the market ready to accept this product, right? I think that's really cool. If you can spot those things, it's really powerful. There's about 600,000 made in Japan per year, but they're also, again, made everywhere where they're used, all over the place. And in red, I've put emerging markets. So they're relatively inexpensive for a vehicle. They're still quite affordable for a middle-class family. Also, another historical and cultural event that happened, in 1973, soon after they launched this, the oil crisis happened. So there was a big oil shortage in the world. Do you have an idea of what American cars looked like at that time? Like that. Enormous. Just massive. Like, this is like, God, over 5 meters long. It's huge. And so these had big V8 engines. They used a lot of fuel, but all of a sudden, fuel was more expensive and it was a lot more scarce. And that primed the market for economy cars. This is when the sales of these really increased and people wanted them more. And so Toyota did not plan for the oil crisis, but Toyota absolutely benefited from it. So if you can spot those opportunities, use them to your advantage. Okay, now the next 4 products are what I'd say are like developing world products. And I guess I'll just launch right into these. So this is the D-Light. This is the world leader in like solar lanterns. They've done 12 million. This is the Jaipur Foot, made just south of here. They've done about 1.6 million since the 1960s. Treadle pumps, which are very popular, well-known, developing world technology. There's been about 1.4 million done by International Development Enterprises. They're kind of the leader in this space. And clean cook stoves is a very common theme in like sustainable, appropriate developing world technologies. There's been about 1 million of those. Now, why I bring all these up is I want to juxtapose them compared to these other products. When I was designing my course at MIT, I thought a lot about like how design and technology for the developing world is usually portrayed. And it's usually portrayed in these type of products. These products that are meant to help people. Some of these, this one and this one certainly, are sold through free market mechanisms. But the level of dissemination of these products is nothing compared to the rest of these, right? And so I think it's valuable to think about what what caused all of these other products to reach such high levels of dissemination? And can you actively think about those when you're designing a new technology? If you're designing, say, a clean cook stove that is meant to improve people's health, what happens if they don't perceive any negative effects on their health? What happens if they have a cultural aspect in how they cook that makes them use their current stoves? What if they like the taste of food using their current stoves? You're maybe not appealing to what makes them buy a product, what makes them like a product. Whereas if you have something like a phone that gives you now an ability to talk to people, ability to text people, ability to transfer money between places, it appeals to maybe a lot more desires, right? So I want you as designers to have a broad perspective, to think about what are all the facets of a design, not just technical, but also how a person's going to interact with it, and also how that design's going to interact with the world that you can use to your advantage. And I think the examples I gave early on, you saw very clear reasons why the market helped facilitate them, as well as people's desire to use them, as well as like their price points. They had a lot going for them. So if you can actively define those, you're in a good position. Yeah, so read the technical and socioeconomic landscape and identify these design freedoms you can exploit to ideally make a global impact with your technology. So I think that's a good actual stopping point before we go into talking about other making things aspects. I'm going to talk about most critical modules next. So I think this is a good time, yeah, it's about 40 minutes. So a good time maybe to break for lunch, if that's okay with you, Jitendra.
Yeah.
Okay, great. So we're going to come back and we're going to talk about making things, and then we're going to do an exercise this afternoon where you're going to break into teams again. So yeah, why don't we stop the video, and I'll see you in what time? We're going to get back together. 2:30?